a rock is thrown vertically upwards with a speed of 10 meters per second. Determine the time it takes to reach max height, the time it takes to reach its original position, and what is its speed when it reaches its original position. So again, we're going to set the reference frame at the rock, and then we're going to write what is known and what we're trying to find. So we know that our initial position in the y is 0, our final position in the y is 0, our initial velocity in the y is 10 meters per second, and then we also know that the velocity at the very top is also going to be 0. And we know it's 0 because it's going up and then it's going down, which means at some instance in time it has to be equal to 0. And we're going to try to find our final velocity, Vy, and we need to know the time. So what we're going to do is we're actually going to use the first equation where we have Vy equals Vy naught minus 9.8t to find the time it takes to reach max height. We can do this because we know that our final velocity is 0, and then we know that we can do Vy naught equals 9.8t. So t is just going to be equal to our initial velocity divided by 9.8, which equals 10 divided by 9.8, and we get 1.02 seconds. So for part 2, we're trying to find the time it takes to reach its original position. We're going to use the second equation because we know everything but time. So our final position equals our initial position plus our initial velocity times time minus 4.9 t squared. And in this, we know that our final position is 0, initial position is 0, and then we know our initial height, or initial velocity. So we know Vy naught t is going to be equal to 4.9 t squared. We can cancel a t, and then we can find that t is equal to 4.9, or our velocity divided by 4.9. And we find that that is going to be 10 divided by 4.9, which equals 2.04 seconds. And you'll notice that that time is double what we had for the time to reach its max height. So we can find that it's symmetric. So now what we can do is we can now find the speed it takes to reach its original position by using equation 1, but now using the time for the final. So we do Vy equals Vy naught minus 9.8t. And in this case, we don't know what our final velocity is, so that's what we're trying to solve. So we get Vy naught, so we have 10 minus 9.8, and we plug in the t for the final, which is 2.04. And what we do is we find that the velocity is negative 10 meters per second. So essentially we start with a velocity of 10 meters per second and we end with a velocity of a negative 10 meters per second.